Okay, in this video I'm going to show you how to do an independent samples t-test in Jamovi. I'm going to do example 1, hypnosis. So we had 2 independent samples. They were shown a video, and then later they're asked like how much they recall from it. So the independent variable is whether they were hypnotized or not before they were asked to recall. And the dependent variable, remember, always needs to be continuous variable. So it's the amount of information they correctly recalled. One thing that I forgot to point out is these are 2 different people. Either they were hypnotized or they were not. So we have 2 independent samples here. Let me show you what the data looks like in Jamovi. So here I have the hypnosis score, how much they actually recalled. Let me click on that. How much they recalled correctly from the video, and there was like 30 questions, and I'm assuming they took like an average of that, like how many they counted, how many they got correctly. This is going to be our independent variable. Notice how it's always nominal. Let me double click on that, nominal. So it's a 1 if they are in the hypnosis condition, and it's a 2 if they're in the no hypnosis condition. And then I put the labels in there so that it would populate this. So first let's do the little box plot. So I would go into analysis, exploration, descriptives, hypnosis score, and I'm going to split it. So what this is giving me is the mean and the standard deviation. Let me just uncheck everything else for everything for the 2 groups combined, and that's not very useful because the whole goal of this section is to compare the 2 independent samples. So what I'm going to do is I'm going to split it by hypnosis condition. So here I have the 2 means, I have the standard deviation, and I believe our problem gives us the variance. So let me check the variance just for fun. 15.6, 34.3. Let's go to the problem. There you go. That's the variance. That's the n. That's exactly what we have here. And that's the sample mean, 23 and 20.8, sorry. Okay, so that's the descriptives right there. The other thing that I can have here is I can scroll down to the plots menu, and I can do box plot. I don't actually have to do anything else regarding the plots because I already split it by condition. So as long as you don't take that out, it will produce the hypnosis score plot and the 2 box plots, and you can compare them, like eyeball them here. They actually look really different to me here, but when we actually did the test, they were not statistically significant. How are we going to do the test? We go into analysis, t-test, independent samples. We're going to put the dependent variable, which is usually the one with the ruler icon, and then the grouping variable. The other name for grouping variable would be independent variable. And notice how it only takes the nominal or ordinal here, so it wouldn't let you do something weird. It gives me the little output for my test. That's actually pretty close to what we got. We got like 1.23. My degrees of freedom, the p-value. Here in the menu, you don't mess with this section, just leave it as students. Hypnosis is going to be 2-tail. That's what we just want to see if there's a difference. Do not mess with missing values. In additional statistics, we're going to click mean difference and confidence interval. So this one won't become available until you select mean difference. So mean difference, confidence interval. And then now it's here. Our confidence interval, it's a little, we're off by a couple of decimals when we did it by hand, but that's fine. I recommend you check the descriptives. Here I have the mean, the sample mean again, and the standard deviation. So if you wanted to go back and recreate this table from this table, all you had to do, you would have to do the opposite. You would have to square this value. Okay. The other thing we have to check is the normality test. We have a couple of options here, but we're going to go with QQ plot. That's actually, I mean, roughly normal, I would say. It's not perfectly normal, but it's not crazy as we have seen in the past. It helps us that we have, a decent sample size, closer to 30, slightly over 30. So I would actually go ahead and say this is normal. so now let's look at the output from Jamovi. So notice it's an independent samples. This is our T obtained. This is our degrees of freedom. This is our p-value. This would be the difference between these two sample means. This is our x bar essentially. This is our S, standard deviation. This is just our sample size. This one over here. Confidence interval, it's a little off, but the direction is still the same. The conclusion would still be the same. We also have our p-value. Normally what we do is that we compare our p-value to our alpha. So alpha was 0.05. We know also that we need to make sure that when the alpha is 0.05, this should be 95. If it was 90, then the alpha would be 0.1 and so on. There's a relationship there. If our p-value is greater than our alpha, which it is here, this is greater, we do not reject the null hypothesis. Do not reject the null hypothesis. We are doing a two-tailed test. We know that our T crit was 2.042, and over on this side it was negative 2.042 T crit. Our T obtained was, it was 1.23. So this is our T obtained. It is not on the rejection region, so we also decide to not reject the null hypothesis. Okay, from here I have all the information that I need. I usually start with the name of the test. So I did an independent samples t-test, the significance level that I use, kind of a little story about what were you comparing, like what were the two different samples that you were looking at. We decided not to reject the null hypothesis, so that's the next thing we have to say. Do not reject the null hypothesis. Whenever we do not reject the null hypothesis, it also means that it was not statistically significant. So that's the next thing that we say. You can put the means and standard deviations for the two samples that you're comparing. Here it's going to be your degrees of freedom, your T obtained, the p-value, and you will get this one from software, and then the confidence interval over here.